Hello, this is section 8.6, solve radical equations. A radical equation is an equation that has a variable in the radicand of a radical expression. Our key strategy to solve radical equations is to isolate the radical on one side of the equation and then raise to the index power to eliminate the radical. Note that we need to check for extraneous solutions when solving radical equations with an even index. So we check to make sure our solutions don't produce a negative under the radical. Example 1. Solve the following equations involving radicals. Part A. Square root of x minus 8 equals 0. So I'm going to isolate the radical. Get the square root of x is equal to 8. Raise each side to the index power. The index here is 2, so I'm going to square both sides, and we get x is equal to 64. Check the work. Square root of 64 minus 8, 8 minus 8, 0. It checks out. Part B, I'm going to get the radical by itself, so I'm going to subtract 6 from both sides. Get the square root of 3x is equal to negative 6. I'm actually going to stop right here because I notice a square root can never equal a negative number. So because this equation says the square root of a number equals negative 6, I know there's no solution to this equation. Part C, cubed root of 2x plus 1 minus 2 equals 3. I'm going to add 2 to both sides. Get the cubed root of 2x plus 1 is equal to 5. And now I need to raise each side to the index power. Well, the index is 3 here, so I'm going to raise each side to the third power. And then we get 2x plus 1 is equal to 125. Subtract 1, subtract 1. 2x equals 124. Divide by 2, divide by 2. X is equal to 62. And go ahead and check my work. Cubed root of 2 times 62 plus 1 minus 2. So we get the cubed root of 125 minus 2. 5 minus 2, which is 3. It checks out. Part D, 3x minus 2 to the 1/4 power plus 3 equals 5. Now you might think there's no radical here, but we just have to remember that fractional exponents are the same thing as radicals. So I still want to subtract that 3 from both sides. And then we get 3x minus 2 to the 1/4 power is equal to 2. Now I want to cancel that 1/4 out, so I'm going to raise each side to the 4th power. So we get 3x minus 2 is equal to 2 to the 4th power, 16. Add 2 to both sides. 3x is equal to 18. Divide by 3, divide by 3. X is equal to 6. Now I need to check my work. 3 times 6 minus 2 to the 1/4 power plus 3. 16 to the 1/4 power plus 3. 2 plus 3, 5. It checks out. Now, part E is a little bit different because you have two radical signs. Whenever you have two radical signs, it's going to be impossible to get the radical by itself. Instead, you get one of them by itself, and then you raise to the index power. Well, we already have the square root of 3t plus 1 by itself, so I'm going to square both sides. So we get 3t plus 1 on the left. But remember, when you square that right-hand side, that becomes 2 minus square root of 3t times 2 minus square root of 3t. So this becomes 3t plus 1 equals 4 minus, so that's 2 times 2. Then we would have 2 times square root of 3, and we'd also have square root of 3 times 2. Those are the same thing, so we would get negative 4 square root of 3t. And then we would have square root of 3t times square root of 3t, which is just 3t. but negative times a negative is positive. So now we have a radical in our solution still. So we have to get that radical by itself. So I'm going to subtract 4 from both sides and subtract 3t from both sides. We get negative 3 equals negative 4 square root of 3t. Divide by negative 4, divide by negative 4. We get 3/4 equals square root of 3t. Now I square both sides. Get 9/16 equals 3t. Multiply both sides by 1/3. We get 3/16 is equal to t. And I'm going to leave it up to you to check this solution. Okay. Part F, square root of p minus 1 plus 1 equals p. So you still want to get the radical by itself, so I'm going to subtract 1 from both sides. Then we get the square root of p minus 1 equals p minus 1. Square both sides, we get p minus 1 equals p minus 1 times p minus 1. That then becomes p minus 1 equals p squared minus 2p plus 1. And now we have a quadratic equation. So remember, we want to get 0 on one side when we have quadratic equation. And then factor. Then set each one equal to 0. So you get p equals 2, and we get p equals to 1. And again, I'm going to leave it up to you to check these solutions, but both of them do work. Part 2, solve radical equations with two radicals. When a radical equation has two radicals, our strategy is to isolate the more complicated radical first and eliminate it. Sometimes after eliminating a radical, we still have radicals in the equation, so we repeat our process. Example 2, solve the following equations involving radicals. Part A, square root of 5x plus 3 equals the square root of x plus 11. Already, the radicals are by themselves, so I'm going to square both sides. We get 5x plus 3 equals x plus 11. Subtract x, subtract x, subtract 3, subtract 3. We get 4x equals 8. Divide by 4, divide by 4. We get x equal to 2. And I'm going to let you check the solution on this one as well, but it works. Part B, square root of m plus 1 equals the square root of m plus 9. Well, the square root of m plus 9 is the more complicated radical, so I want to get that one by itself, which it is. So now I'm going to square both sides. This becomes the square root of m plus 1 times the square root of m plus 1, which equals m plus 9. Don't forget, you have to distribute this, but square root of m times square root of m is m. Square root of m times 1 is square root of m, but then 1 times square root of m is square root of m. So that gives us 2 square root of m, and 1 times 1 is 1. Now there is still a radical, so I want to get it by itself, so I'm going to subtract m from both sides, subtract 1 from both sides. We get 2 square root of m is equal to 8. Divide by 2, divide by 2. Square root of m is equal to 4. And now the radical is by itself again, so I'm going to square both sides. And we get m is equal to 16. Now, as a reminder, you want to check this answer, but it does work. 16 is our solution. Part C, the square root of x minus 1 plus 2 equals the square root of 2x plus 6. Now here, it doesn't really matter which square root you get by itself, so since the square root of 2x plus 6 is already by itself, I am just going to square both sides. And then this becomes the square root of x minus 1 plus 2 times the square root of x minus 1 plus 2 equals 2x plus 6. Well, square root of x minus 1 times square root of x minus 1 is x minus 1. And then the square root times 2 and 2 times the square root will combine, giving us 4 square root of x minus 1, and 2 times 2 is 4. We still have a square root, so we have to get the square root by itself. So I'm going to subtract x from both sides, add 1 to both sides, and subtract 4 from both sides. And we get 4 square root of x minus 1 equals x plus 3. Now I'm going to square both sides. This becomes 16 x minus 1 equals x plus 3, x plus 3, which is 16x minus 16 equals x squared plus 6x plus 9. So now we have a quadratic equation, so we want to get 0 on one side. So I'm going to subtract 16x from both sides and add 16 to both sides. We get 0 equal to x squared minus 10x plus 25. Factor that, we get 0 equals x minus 5 times x minus 5. Well, since both of those are the same, we just get x minus 5 is equal to 0, or x is equal to 5. And when you plug that in, it will give you the correct answer. Yeah. Now I have the fourth root of 3x equals the fourth root of 2x minus 5 equals 0. So I'm going to subtract the fourth root of 3x from both sides. So that gives us the fourth root of 2x minus 5 equals negative fourth root of 3x. Raise each side to the fourth power. We get 2x minus 5 equal to 3x. Subtract 2x from both sides. You get negative 5 equals x. When you plug this in, and just into the first one, you get the fourth root of negative 15, which is an even root of a negative number. It does not work, so there is no solution to this equation. And that is it for section 8.6.